We present Strayed, a research platform for shape-changing spatial displays based on actuated strings. With our work, we contribute a design exploration of string-actuated spatial displays for dynamic and situated physical visualizations. Furthermore, we realize a physical research platform based on modular components. To prototype, explore, and evaluate new applications, we provide a suite of easy-to-use developer tools. We implemented several applications based on 3 distinct physical setups to confirm the technical feasibility of our platform. Finally, we elaborate insights and lessons learned from our iterative development process. Strayed helps to prototype spatial displays that can be customized along various design parameters. Although they equal conventional pin arrays, we rather employ a string actuation from above, similar to string-based art installations. Depending on the use case, each element can have different geometries, sizes, or materials. Furthermore, additional output and shape-changing capabilities can be added. The string-based actuation mechanism facilitates large strokes with fine granularity. Depending on the visualization's requirements, the elements can be arranged freely, like on a linear path. Alternatively, a matrix arrangement along a regular grid facilitates 2.5D visualization similar to pin arrays. Elements can be used as individual points, for instance in a scatter plot, or can be combined into lines or 2D characters and shapes. Additionally, interconnected elements create continuous surface visualizations. To enable interactive applications, Strayed facilitates touch or drag input. We conducted a series of tests to realize a modular physical hardware platform. We experimented with a variety of elements of different shapes, sizes, and materials. Additionally, we implemented shape-changing structures and interactive elements. Using off-the-shelf components and digital fabrication techniques like 3D printing and laser cutting, we iteratively developed custom laser cut mountings for NEMA 14-stepper motors. These are stacked in an actuation tower, which is the base module of Strayed. The towers can be assembled into physical instances. We demonstrate a single setup with 1 tower, a linear setup with 16 actuated elements, and 8x8 elements in a matrix setup. Development for shape-changing displays is challenging. To enable easy development, we realized a set of tools that support the ideation and implementation process. To brainstorm novel visualizations on the physical device itself, we provide a visual designer. It is a web-based tool that provides 2 canvases for sketching colors and positions of the individual elements. To facilitate development in desktop environments, we created a platform emulator. It represents the physical hardware and allows to create applications without the need for a physical instantiation to be around. Finally, we envision augmented reality representations of the whole system. They support development in environments where the display is intended to be placed. This helps to evaluate the relation of the device with its environment, including appearance and ambience. We developed a set of representative use cases for each of our 3 physical setups. In a private context, individual elements are used as ambient visualizations, like this raindrop conveying the water level of a plant. The envelope is used for ambient notifications, as the lid is opened every time a new message is received, and its vertical position encodes the number of unread messages. Pendants serve as decorative controls in a smart home environment, for instance, to control hue and brightness of lights. Our linear setup features 16 actuators to augment a whiteboard. A physical line is bent to create a dynamic graph with hand-drawn axes and direct input controls. For visual storytelling, Strayed actuates icons according to a hand-drawn scene. These physical props assist the presenter in creating engaging and animated schematics. Our weather application on the 2.5D matrix setup presents the real weather forecast by visualizing sunny, cloudy, rainy, stormy, or foggy conditions. To demonstrate the possibilities for entertainment applications, we introduce a memory game in which players have to find pairs of spatially arranged elements. We further wanted to visualize data from the environment. These shapes are morphed based on currently played music. As shown, our applications combine dynamic visualizations based on real-world information with direct and remote input. Overall, we hope that our work inspires future research towards rapid prototyping of physical visualizations and shape-changing spatial displays. For further details, please refer to our full paper.